Hello, can you hear me? Yeah, good. Okay, welcome to my talk, Oden, a functional programming language for the Go ecosystem. So, my name is Oskar Wickström. I'm from Malmö in Sweden. I work there and I live there. And since November last year, I've been working on this project on my spare time, so nights and weekends. And this is a very young experimental thing, so you should not use this in production tonight or not tomorrow either. Well, first off, I just want to thank my employer for making this trip possible. And today we will look at the agenda, or sorry, at the background of this project, why I started it, the specific goals for this project, and like the motivation. We will look a bit at the current state and what's coming up next, perhaps, and we will have some time for questions, I think. So starting with the background, I've been thinking about some things last couple of years, and I just want to throw them at you so you get a sense of like where I'm at. And here are those thoughts in no real particular order. So I want type-safe functional programming for writing web applications and servers, because that's mostly what I do. And well, Haskell is perhaps an option, perhaps my like favorite option right now. I don't really get along with Scala. I shouldn't say too much about that. Controversial, perhaps. I think it's too complex. And then there's languages like Rust, perhaps not that mature in web app development, and also not like the abstraction level I'm looking for. And of course there's like Java 8 with RX or streams and stuff, and I guess that's okay, but it still hurts when you have to work with data, and that is something that I do, and I think that's something you do as well. So I'm kind of conflicted where to go here. So I think Haskell is a great language in any case, and maybe it's the answer here. Maybe I should just like focus on Haskell, learn the web application stuff for Haskell, and help that community grow. And then like there's this Yesod framework, seems promising. I haven't learned it yet, so. Though I think Haskell has some like pain points for writing production software as well. To me it feels still like researchy, even if you can do like pragmatic stuff. Sorry. The tooling is a bit messy still. There's this project called Stack, which improves things greatly, but there's more to do there, I guess. And the flexibility of Haskell might be a pain point as well, because you have all these language pragmas and things like template Haskell. You don't have to use that, but it's there and people are using it. So I think there's a lot of complexity. And it's like Haskell is a bit too big in terms of features and cool stuff, which may be less pragmatical and more like researchy. So could we have like the safety of Haskell, but in a simpler language? So I'd like to have less decisions, which of the 100 language pragmas do I have to use, and so on. I want like a concise standard instead. I want to debate with every person how I should indent my source code. And in this regard, I think the Go language is doing very well. They have like a kind of strong consensus on the conventions of writing their code and how it should work. Okay, I want fast, like clean slate compilation as an option. And what do I mean by this? So first off, I should say I really love doing REPL programming, like interactive programming. And I work with Clojure mostly in my daytime. So there's this thing, I feel like I'm forced to use the REPL in Clojure because it's impractical to be on the command line and run line compile all the time because it takes too much time. So I'm kind of forced into this interactive development flow, and it's good to be able to do interactive stuff, but I end up having like strange errors in the REPL, and it's like I have this state in my compilation that can live for hours or a complete workday, and then I end up restarting the REPL and nothing compiles anymore because I had some kind of order state which I changed or renamed a definition somewhere, or that's like a source of complexity that I'm having a hard time to trust the workflow kind of. So I want to have the option to go out and do a fast clean slate compile as well. I'm not saying we shouldn't use REPLs. And this is a biggie for me. I think we should optimize for writing code that is correct, understandable, and safe to change. So I don't like hunting down like silly programming errors in runtime. And I want other people to be able to understand the code that I write and that others write. And I'm going to talk a bit more about that later. And like ideally, changing existing code should feel as safe as writing new one, I think. And that probably isn't ideal, but anyway. And when it comes to the aspects of correctness and safety, I think Haskell is doing very well and something to strive for. And we should not optimize for cleverness. So I think like writing dense code, one-liners and such, they may be very good for your ego, but not so good to maintain for a project. Also, like hiding essentials in code. I'm thinking of having implicit stuff or like magical monkey patching things in Ruby or whatever. It's like a trade-off. I think we should have abstractions for things that are not essential, and we should like emphasize the things that are essential. And that's what abstraction is all about, I think. And another thing on this subject is macros. So there's this argument that Clojure or Lisps are easier to learn because there are very few like built-in forms, and you have to learn like 10 or 15 things, and you're done, and you can read all programs. And I kind of disagree, because I think these languages has a lot of syntax, but it isn't defined in the reader or in the core language. It's defined in terms of macros in libraries and everywhere. So it still has a lot of syntax, but you have to learn it some other way. Okay, jumping back to the type-safe web application stuff. Maybe I should do like static typing on top of JavaScript instead. So I've been tinkering with this language called PureScript, which is really cool. And you can run that on Node.js. So that's an option. And then there's things like TypeScript or Flow, more like external type checker things. But all these tools require some kind of FFI bindings and or some kind of annotations saying that like this JavaScript function, this native function or foreign function has this type or works this way. You have to create an explicit adapter of some kind. So having to write these FFI bindings and adapters is quite cumbersome and makes a new language take time to adopt and make it usable. So I want like the compiler to do this for us instead. So if we compile to a language that already has a static type system, maybe we could query that type system and let the compiler do this work for us instead, generating wrappers and stuff. So also, can we reuse on that subject? Can we reuse the good stuff from a language like Go, which has this static type system, but instead use a functional language? There seems to be a lot of people writing Go, libraries, tools, whatnot. maybe all of them don't want to convert to Haskell. I don't know. I don't think so. They seem to like it there, and I'm wondering, like, can I some way reuse the good stuff, the runtime and so on, but in a functional language instead? And I think I can, and we can. So this is not like the official slogan for this project or anything, but I try to be positive. But with this conclusion, I started working on this project called Oden. So first I'm going to talk about why Go in this case. So it has a growing ecosystem, lots of libraries and tools. It has support for in-process concurrency with like lightweight threads called Go routines, and they have channels for communicating between these Go routines. Cross-compilation is easy in Go. You can compile for Windows on your Mac and so on. And it's easy to do static linking, which is nice for deploying servers, I think. Also, the specification for Go is quite small. It's a simple language. And the compiler is very fast at compiling Go code. So in this case, we can use transpilation to Go source code, and it works reasonably fast anyway, even if we have like 2 compilation steps. So there's some drawbacks with Go as well. The first thing is expressions over statements. I like having expressions, not statements with side effects. So I want like if, switch, for, and so on to be expressions. And that also includes the Go has this keyword called Go, like the slogan thing, I guess. And that's used for spawning a new Go routine at a function call. So it doesn't return anything useful. I think it could. Generic programming, this is a kind of overloaded term and kind of controversial in the Go community. I guess they're talking about their generics a lot. So Go has no like parametric polymorphism. You can't write type-safe generic functions like map, filter, and so on. Every one of those. And on the same theme, you can't write a polymorphic type-safe data structure like your own sorted set or something like that. And the Go community seemed to have settled at templates and code generation, which are kind of crude tools. Abstraction, I think, is missing from Go as well. I'd like to have something like a monadic maybe type instead of doing nil checks everywhere. Also, error handling. In Go, error handling is explicit. They have a panic feature, but mostly you're returning error values and checking them manually. So in a sense, that's good, I think, having errors as values, but the checking is very tedious and easy to introduce errors with. So if we look at this code, I don't expect you to see everything. It doesn't matter, actually. This is a function I wrote a couple of years ago. I'm not going to win any prizes with this function, but I think it's like a standard Go program function idiomatic code. This is what most Go code looks like that I've seen, at least. So what I want to focus on is this part. So the stuff that I kind of dimmed out is error handling, boilerplate, and the other stuff is what I care about, basically. So the gray stuff, it's this thing all over and over again. It's just checking if the last thing returned an error, and in that case, early exit with that error. So I would argue this is quite error-prone, having to do this in between every operation, and quite boring as well. So when I wrote this talk, I found another issue with the previous code sample, this red part. So I don't know if you see it already, but there's this error check actually doesn't check anything that hasn't been checked before, and it's an error that I made. So it's totally harmless. It doesn't do anything bad, but I missed this. And actually the IO copy operation from before returns an error, which I didn't know, and I didn't get any warning and so on. And then I wrote this error check because I was kind of I guess I was in like a mode that I have to write an error check in between everything I do, regardless. So all the noise kind of made me miss this. So the goals for Oden then. First off, I want to use Go as a platform, basically, because like David said in the keynote this morning, that Clojure isn't an island. It builds on top of the JVM and on JavaScript. And I really like to do the same thing because, let's be honest, if I'm doing this myself, I don't have the time to do like the whole stack. So it's more reasonable to build on top of Go. And this is comparable to Scala for the JVM or Elixir for Erlang, I guess. And avoid cleverness and prefer clarity. So maybe a bit fluffy, but I'm like happy to write an extra line of code if it makes it more clear what the program is doing. Expressions over statements. This was what I talked about earlier with if, switch, and go, and so on. Support generic programming. So this is like the holy grail of Go debates, I guess. So I don't think copy pasting code and changing the types for every instance is a good way to program. And I don't think writing the same for loops every time you have to do a filter is a good way either. And I think it's harder to understand that code in the end when it's written as well. Because I've heard the opposite opinion on this quite a lot, but I think it's harder to look at the for loop, and then you have to like abstract that when you're reading it and think, yeah, okay, it's a map or it's a filter or some kind of fold, and the abstraction isn't there, and you have to map it all the time. So also, I think we can do better than templates and code generation in the like external tool, just writing Go code kind of way. Also support good abstractions. So this is to reduce the risk of making errors. You can use like proven tested code that works, and make it possible to abstract things like boilerplate stuff like nil checking or error handling that we saw before. Type inference. I want like the top level types to be perhaps be required or at least encouraged, like a warning if you don't have a top level type signature. And I'm going to say I've cheated a bit in my code samples later on, so I'm not dogfooding this yet. Anyway, the rest of the types should be able to be inferred by the compiler inside the function bodies and so on. But you should, of course, be able to explicitly type annotate something if you want. So this is like the Haskell approach. Also, I think immutability by default in data structures is like a clear win. I haven't done any work on this yet, but yeah, it's a very big area, so we'll see. But Go is like pitched for writing concurrent applications with thousands or millions of Go routines. I think having immutable data structures is a clear win in that case. Pattern matching, I like to have that as a preferred way of doing control flow instead of just having ifs. And related to that is exhaustiveness checking. See that you have matched all your cases. Also, I like to have, this is like the key, one of the key features of this project is to have a simple interoperability with Go. So this is the FFI bindings I talked about before. You should just be able to use Go code, and you shouldn't have to write the adapters for everything. And I think it can work, and I've done some work here, so I'll show you later. But being able to just build on top of, say you want to write a HTTP server or whatever, you don't have to first wrap it or find someone on the internet that has done the wrapping, because no one has right now. I also want this programming language to be fun. So it should be easy for newcomers to get started with this and have like a low threshold for get going. Open source from the beginning. This is kind of scary. So I published this quite early. Basically, the first version I got something working in, and eventually it landed on Hacker News and Reddit, and the rage began. So that's scary. Anyway, the good part of having it open source from the beginning and ending up on Hacker News, I guess, is getting the critique and the feedback. And I think just if I shut myself in for like 3 years and write this with what I know, I don't think the result is going to be really good. So even if it's hard, I like having some kind of feedback. So come pick at me and tear it apart, and we'll find something better. Also, I think, yeah, it's generally it will be better if a group of people write this. So this is the MVP pyramid, it's called. This is a thing that I like to try on this project. I'm not sure about like compiler projects, how they're usually done, but I'm pretty sure people don't use the MVP model that often. Perhaps it's starting to move that way. If you look at like Elm, they have seem to do a lot of work on the user experience stuff and so on. But what you see here, the blue slice, is how you like prioritize your features and how, the amount of work you do on a given feature. So you make it work, of course, but you also make it like usable and create this kind of emotional layer on top. And this is basically the Hello Kitty part of the implementation, I guess, having the nice logo and nice design stuff. I think it's fun to work with as well, so I don't mind doing that. And I think it makes it easier to approach for beginners and for newcomers. So this is kind of my strategy, and it should affect all the parts of the project, not only the syntax and the language, but also like the website, documentation, command line tools, and error messages, and everything. So we looked at the goals and background for this project, and so my focus so far has been mostly on the stuff of like the highest uncertainty things. Yeah, well, the type system, the basics that just has to be there. So there's a lot of stuff not done yet, very early, and yeah, the first compiler was written in Racket, actually, using Minicanron for the type system, and that worked very well. It was a great way to start, and I got something working very fast. And later, I actually rewrote the compiler in Haskell instead, because I wanted kind of more safety when doing the refactorings. Usually, the significant refactorings touch all files, and it's like total chaos, and 2 weeks later I'm out on the other side and stuff works. So I like the support of Haskell in that case. And also writing compilers in Haskell is kind of neat. Anyway, let's look at the current state of Oden, some of the features. I'm just going to highlight some parts, because I don't have time to show you everything. The first example of a hello world, of course. This is the main package with the main function taking no argument and printing hello world, which returns the unit type. So I could mention here as well, Oden has no explicit like effect system or something. You can do side effects. I'm not sure about the design there. I'm kind of crunching different approaches to perhaps encoding effects in the type system. I'm not sure about that yet. These are the built-in infix and prefix operators. Look kind of standard, like in Go, I guess. The main difference here is that these are just syntactic sugar on top of something called protocol methods. And I'm going to explain what protocols and these methods are later. But with this support, Oden has gets support for operator overloading. So here's the translation rules for which operator becomes which protocol and method call. We don't have to go through all these. Just wanted to show you. And then there's no custom operators right now. You can't define like the hash rocket or fishbone, whatever. I actually think there shouldn't be a way to do this because it feels like it encourages the cleverness things rather than being pragmatic. So what you can do right now is overload the built-in overload the built-in operators. There's no macros right now, at least. I try to keep the language as simple as possible, and I'm kind of striving to not have macros because I'm not really sure that I want to have them. In basically, I want to make it possible to do abstractions on top of like monads and applicatives rather than having arbitrary metaprogramming constructs. We'll see how that works out, but I think it's simpler, and you might have to write like an extra line of code with this, but I think it's worth it. So Oden has curried functions. Both the Oden functions you write in Oden and the functions from Go get curried automatically. So in this example, I'll explain it quickly. The plus function takes two values, and yeah, you can see what it does. The twice function takes a function f and some value x and applies the function twice. The plus 20 is like a composition of the plus and twice function, and so we apply plus to 10, get another function back because we only applied one value, and then we apply that to the twice to that result, and we get another function back. And on the last line, we apply the resulting function with the value 20, and we get 40 because the plus 20 does addition with 20. So just to illustrate this, we can add some type signatures. Then it looks like this. And we can see a bit more clearly what's going on here. The twice function is polymorphic. You see the for all keyword is used to introduce type variables in a signature. And also the plus function you see here is less general than it has to be. It's restricted to only work on integers in this case, but the infer type is actually more general. You can import packages from Go, and here we see a program that imports the HTML package from Go and uses the escape string function to print Simon and Garfunkel in HTML safe code. And the automatic import thing from Go is kind of restricted right now. It's only simple functions with simple types that work. So this is supposed to be improved later on. It puts some restrictions and some demands on the Oden type system to be able to make that mapping, but I think it should work. So I did some hacking on the flight here, so this code might look like this in a couple of days instead. That's because of the Go specification says nothing about the package import paths. It's totally implementation specific, so that's the reason for it being a string here. I've implemented a basic version of records. And these are pretty much like Elm and PureScript records. So there's some stuff left to do here, but I think it's promising. So here we define two values, Sweden and USA. The type of these records look like this. And we can create functions taking records, record arguments, and accessing their fields, as you would expect. And so you see here, not like in Haskell where the labels are functions, but here instead they're accessed with the dot syntax. So if we look at the type signature from this function, taking a record, we get this. This is the inferred type of the function, inferred by the compiler. And we see here that we receive a record, and we have this polymorphic type variable called R. And this is used to enable something called row polymorphism. And essentially it means we take a record that has at least first name and last name fields and possibly more fields. So the function is polymorphic in the sense that the record shape can vary. And this is actually, this came naturally from having type inference and records. I found this way of having a nice interaction between the type inferencer and the records. So this is the same as in PureScript, but more naive right now. And then there's this thing called protocols, which I started talking about earlier. So the spoiler here is that these are like type classes in Haskell. There's nothing new here, and they're not like protocols in, say, Clojure. They're like type classes. But I wanted to pick another name for it, not just to be cool and have my own name, but I got kind of confused with the name type classes when I started looking at Haskell. So this is a quite recent addition, and it's super limited right now, but it works kind of like this. You can implement some protocol for some type. So here we implement the built-in monoid protocol for records representing points in like a 2D space. So we say implement monoid for this record type with x and y int fields, and then there's two methods in this protocol that we have to implement, the apply and identity methods. And when we have that, we can create two values of this type, and we can apply the method on those values. So here we apply mono apply on position and distance. But as the operators are desugaring into protocol methods, we can also write it like this. And well, yeah, these two are equivalent. So plus plus will become that. So this is how you get like the operator overloading for user-defined types and so on. So this protocols feature maybe isn't that simple. I've been talking about simple languages and not having like complexity, striving to have a less complex language. And I think this is the most complex feature right now. And yeah, I guess type classes gets this critique as well in Haskell. It's quite complex to see which implementation does the compiler choose and so on. And maybe I should explain as well the implementation, the dispatch in this case is done at compile time, not at runtime. However, I think the protocols feature, or like the type classes in Haskell, is a very nice way of doing operator overloading or function overloading. So it's like the lesser of evils, I guess. So this was some of the features of Oden right now, and there's more. So if you want to look at this, you can find some more information at the different places. I have the site up at oden-lang.org. There's a development blog, about page with some information about the project. There's links to various other things, like the user guide, looks like this. This is something I've been working a lot on my vacation. I was here in Italy, actually, with a glass of wine, writing documentation. That was nice. So here I try to put the focus on the user experience, having a nice documentation, easy to get going with. So many of the programs, there are complete programs in this documentation, can be run directly in the browser if you want to try them. And also the user guide is available as different formats and ebook stuff and so on. And the ability to run the programs is backed by this site called Playground at playground.odenlang.org. And here you can like tinker with programs and run them in your browser if you like. So this is a nice way to just try this out. You can follow Odenlang on Twitter if you like. Here's the handle. So what's next in this project? It's an experiment. It's very young. I'm doing this myself right now. And there's a lot of stuff left to do. Building a language is, yeah, crazy. So I'm kind of at the stage where I try to evaluate this and see if people find it useful, if it's just for me, or if this is something that should be built. So I really like to hear what you think. You can ask questions very soon and come talk to me afterwards as well and bring all the stuff. So that's it. Thank you. Questions? Anyone?
Hi. Thank you for the talk. I was wondering, you chose Go as the platform to build this on, and while it is early in the project, you might not have a thorough answer on this. I'm wondering what you feel the biggest hurdles to cross have been since you've chosen Go. Like, has Go as a platform obstructed you in some way that you felt like maybe wouldn't happen in some other platform? I don't know.
Yeah, good question, and I don't have like a super good answer, I think. So there was, well, I did this monomorphization phase in the compiler where every instance of a polymorphic function is like instantiated to the monomorphic version, and then they're like compiled out to that form, because that's not like a bad thing with Go having to do that, but it was kind of hard. But I don't see it like a hurdle really. But yeah, if I can come up with something else, I'll talk to you afterwards. Yeah, thank you. Over there.
Yes, I was curious. What is your compilation model? Do you transpile to Go code, or do you compile to actual? Do you have an alternative front end?
Yeah, so I transpiled to Go source code because I tried to find like a specification on calling conventions and so on. Maybe we could like compile through LLVM or something else and hook into Go, but I didn't find anything useful there. And just getting something working and hooking into runtime transpilation was the way forward. Yeah, thank you.
Hi. How are you going to use the Go routines in your language?
Yeah, I haven't found a very good design, like a final design yet, but I like there's this thing called core async for closure, which kind of does the same thing as Go routine and channels. So basically, I'm thinking like steal that straight off, and yeah.
Last question.
Thank you for your talk. My question is, how do you handle compiler errors? So what if the compile thing, when it's compiled by Go, it has some errors there? And do you have some source mapping or something that tells you where it was this thing in the code?
Yeah, so compile time errors, basically Oden has to catch everything. So all the things that would cause a compile time error in Go has to be caught at the Oden compilation phase. And then there's runtime errors, which where the source mapping becomes essential. So there's this, you can like output small comments called compiler directives in Go source code, which tells the Go compiler to treat it as the file and line number that you say. So I did some work outputting those comments, and when you like debug Oden program, which is compiled through Go, in GDB, you get the Oden source information. So, yeah.
Cool.
Okay, let's thank the speaker.
Thank you.